Hello students, AS level chemistry chapter is redox reactions, lecture number 1. In this lecture we are going to talk about what are redox reactions and what are the different definitions for reduction and oxidation that are in your syllabus. We will discuss the first definition for reduction and oxidation in terms of electron in detail in this lecture, and we will also write down some equations as type example for the first definition of redox reaction. Okay, let's start. First of all, you must know what is redox reaction. Redox reaction means it is a combination of red and ox. Red for reduction and ox for oxidation. So what is a redox reaction? A redox reaction is a chemical reaction in which both reduction and oxidation take place simultaneously. Whenever reduction and oxidation take place both simultaneously, this type of reaction it is known as redox reaction. Now, second thing, you must remember reduction and oxidation, they can be defined in a number of different ways. Okay, students, in your syllabus, there are two different types of definitions for reduction and oxidation. One definition that we will study in detail, it is in terms of electrons, and second definition in terms of oxidation state. So these are two important definitions which are in your AS syllabus. Now, first of all, we will define reduction and oxidation in terms of electrons. Now, what you must remember in terms of electrons, how we can define oxidation and reduction. So, you must remember in terms of electrons, oxidation, it can be defined as process of loss of electron. What is oxidation? It is a process of loss of electron. Whenever electrons are lost during a chemical reaction, that is known as oxidation. And what is reduction in terms of electron? Reduction, it is the gain of electron. Whenever an element gains electron during a chemical process, we call it reduction. So this is very simple to remember. How you can remember? Oxidation is always loss of electron, while reduction is the gain of electron. You can remember this oil rig. This will help you to memorize that oxidation is the loss of electron. Oil oxidation is loss, while rig or reduction, it is gain of electron. So you can remember oxidation and reduction quite easily. In terms of electron, oxidation is the loss of electron, while reduction is the gain of electron. So this is one simple definition that is in your syllabus in A level. Now we are going to write down some examples of the chemical reactions that are redox reaction, and we will explain these reactions in terms of electrons. Now how a question can be asked and how you are supposed to write down the answer in your exams. Suppose you are given aluminum oxide, Al2O3, aluminum oxide, and you have been asked to write down reaction equations for reduction, oxidation and redox reaction. So you must remember, you can be asked to write down three different chemical equations for the redox reaction. Number 1, oxidation; number 2, reduction; number 3, redox reaction. Remember, redox reaction, it is a sum of reduction and oxidation. Now what you will do, whenever you are given a chemical compound, first of all you must remember that element, it would be made up of a metal and non-metal. Metals always lose electron easily, while non-metals, they can gain electron easily. How you will come to know? which element in the given compound is a metal. Mostly in ionic compounds, first element that is written in the chemical formula, it is metal, and the second element that is written in the chemical formula, it is non-metal. So right now you can see aluminum, it is a metal because it is written earlier than oxygen. And what is oxygen? Oxygen is a non-metal. Now from the periodic table you can get to know aluminum will lose how many electron and oxygen will gain how many electron. Aluminum, it belongs to group number 3. When it belongs to group number 3, what does this mean? It means its valence shell contains 3 electrons. So if we distribute 3 electrons, what we can come to know that there are 3 unpaired valence electrons in aluminum. So aluminum can lose 3 electrons. Metals, they lose all their valence electrons. So aluminum will lose 3 electrons. When aluminum will lose 3 electrons, aluminum will get a charge of 3 positive. Why it will get a charge of 3 positive? Because number of proton, it will become greater in number compared to number of electrons. Now as compared to aluminum, oxygen, it belongs to group 16. It belongs to group 16, and group 16 elements, they have 6 valence electrons. If we distribute 6 valence electrons of oxygen, what we can come to know, after distributing 6 electrons, we can see that how many unpaired valence electrons are there. In the valence shell of oxygen, there are 2 unpaired electrons. It means oxygen has a valency of 2. So oxygen will gain 2 electron, while aluminum, it will lose 3 electron. Now how you can write down this equation? First of all, you will write down an equation for oxidation, then reduction, and when you will take the sum of oxidation and reduction, it will become redox reaction. Now oxidation is the loss of electron, so aluminum, it will lose 3 electron. When aluminum will lose 3 electron, it will get a charge of 3 positive. So we will get aluminum ion, that is tri-positive ion. Now aluminum has been oxidized. This is oxidation equation. Now as compared to aluminum, oxygen, since it is a non-metal, it can gain electron easily. And oxygen, how it exists in nature, oxygen is a diatomic gas. So oxygen, it will gain electron. One oxygen needs 2 electron to complete its valence shell. Since we are having 2 oxygen atom, so how many electrons we will have to provide? We will have to provide 4 electrons. So one oxygen molecule, since it has 2 atoms, so they will gain 4 electron. When oxygen will gain 4 electron, one atom has gained 2 electrons only. So what charge oxygen will get? It will get a charge of 2 negative, and we will get 2 ions of oxide. 2 ions of oxide will be produced, and you can see the negative charge, it is equal on both sides. Now the first equation that we have written, it is oxidation, and the second equation that we have written, it is reduction. Now if you take a sum of both these equations, it can become redox reaction. Now remember, whenever we take a sum, before taking sum, what we do, we balance the number of electrons in both oxidation and reduction equations, and we cross out, we balance and cancel the number of electrons present in oxidation and reduction. How we can balance the number of electrons? So that we can cancel them. We can cancel them by by having same number of electrons on both sides. So what we do for balancing electron, multiply the first equation by 4. Why? because 4 is the number of electron in the second equation. So you will multiply first equation by 4. So what will happen to the number of electrons in the first equation now? 4 into 3, 12. Electrons have become 12, and we will multiply the second equation by 3. Why 3? Because number of electron in the first equation is 3. So remember, we cross multiply the number of electrons present in a chemical equation. The electrons which are present in oxidation equation, that number is multiplied to reduction equation, and the electrons that are present in the reduction equation, that number is multiplied to oxidation equation. Now what you can see, the number of electrons, it has become equal, so electrons will be cancelled. Now what final equation that you will get, the sum of oxidation and reduction, it will be known as redox reaction. So you can write down Al plus O2, but how many Al? 4 Al. How many O2? 3 O2 gives Al 3 positive plus O2 negative. Now just multiply the number with each of these particles. Aluminum atom will be multiplied by 4. Oxygen will be multiplied by 3. Aluminum ion will be multiplied by 4, while oxide ion will be multiplied by 3, but there were 2 mole of oxide, so 3 twos are 6. Now what you can see? You can see the total charge on both sides. Total charge on both sides, it is equal. This is 4 3, 4 3, 4 into 3, they are equal to 12. 12 positive, 6 to 12 negative, 12 positive, 12 negative. So the charge is equal mathematically. So we can say our chemical equation, it is balanced. Now this is net redox equation, and this aluminum and oxide ion as a whole, they can be known as aluminum oxide. You can write down Al2O3 if you just combine these positive and negative ions, positive aluminum ion and negative oxide ion. Otherwise it is also acceptable if you just keep them written like Al3 positive and O2 negative. Now this is an example, a complete equation showing oxidation, reduction and redox reaction. Now I am giving you one example, just give it a try. You can pause the video, write down the equations of oxidation, reduction and redox, and then I will show you the answer. Okay, the reaction, you are supposed to write down reaction equations for magnesium fluoride. Write down oxidation, reduction and redox reaction equations. Okay, students, if you have written, what first of all you must look at what is the group number of Mg. Mg belongs to group number 2. So Mg, it will lose how many electron? It will lose 2 electron. After the loss of 2 electron, Mg will get a charge of 2 positive. Now this is oxidation. Fluorine F2, it belongs to group 17. Group 17 elements, they have 7 valence electrons. So how many electrons they need to complete their outermost shell? Each atom needs 1 electron. So what we can do, we can write down F2. Since we are having 2 atoms, so we need 2 electrons. One atom will gain 1 electron, and each atom will become fluoride 1 negative ion, and we will get 2 mole of fluoride ion. Now if you want to take a sum of this oxidation and reduction to get a redox reaction, what you can see in this case, electrons, they are already balanced, so you can just cancel them. When you have cancelled the number of electrons, now you can get the redox equation. Mg plus F2 gives Mg2 positive plus 2 fluoride ion negative. Now this is oxidation, reduction and redox equation for magnesium fluoride. Two more examples I am giving you. You can do practice for these two compounds as well quickly. Okay, next example that you can write down, students, for definition of reduction and oxidation in terms of electron. Write down equations for sodium oxide. Okay, if you have written, what you must remember, sodium, it belongs to group number 1, so each sodium atom will lose one electron. When sodium will lose one electron, it will get a charge of 1 positive. Oxygen, it belongs to group 16, having 6 valence electron, so oxygen is diatomic. One oxygen will gain 2 electron, and since we are having two oxygen atom, they will gain 4 electrons. Now when you will take a sum of both these equations, you must multiply the first equation by 4. Now this equation is balanced, electrons will be cancelled out, and the final equation you will get 4 mole of Na plus O2 gives 4 mole of Na1 positive plus 2 O2 minus. This is the net redox equation for sodium oxide. One last example you can attempt, it is chemical redox equations for magnesium nitride. In this case, as you can see, the metal is Mg, magnesium, belonging to group number 2. So 1 Mg, it can lose 2 electron, getting a charge of 2 positive. While nitrogen, it belongs to group 15, it has 5 valence electron, so nitrogen can gain, each nitrogen atom can gain 3 electron. We are having nitrogen diatomic gas, so how many electron it will gain? 2 atoms. One atom, since it gains 3 electron, 2 atoms, they will gain 6 electrons. When nitrogen will gain 6 electron, we will get 2 mole of N3 negative. Now before taking sum, you can multiply the first equation by 3, so that the number of electron can become equal and cancelled out. Now you can write down the final equation, 3 mole of Mg plus N2 giving 3 mole of Mg2 plus 2 mole of N3 minus. Now students, what you can see, by using this first definition, now you people have become able to write down oxidation, reduction and redox equations in terms of electrons. I hope you would have enjoyed this lecture. If you have any question regarding this topic, you can write down your question in the comments below. Thank you.